Welcome to the Idaho Drone Academy, a retention learning program designed to help you pass the FAA 107 Commercial Drone Pilot Licensing exam. This program will focus on METARs, TAFs, and airport sectional charts. The FAA has determined that society needs a uniform, trained cadre of unmanned drone pilots who have undergone specific safety training. Once these pilots are thoroughly trained and have passed the required exam, the FAA wants them to retain a certain level of knowledge and competence as unmanned commercial drone pilots. In this video, the Idaho Drone Academy presents an example of how we train and support this learning. Your lifetime guarantee for the full training comes in the form of a physical manual, one you can hold in your hands, one that will never go out of business, declare bankruptcy, sell out, retire, or die, and that will always be available for review. Be sure to check us out at idahodroneacademy.com. Meteorological Terminal Air Reports, or METARs, are routine computerized aviation weather reports. They include visibility, cloud levels, wind velocities, rain, snow, altimeter settings, and more. They are based on observations. Terminal Aerodrome Forecasts, or TAFs, are weather reports issued every few hours and updated as needed. They're generally considered more reliable. Automatic Terminal Information Service, or ATIS, are current flight information reports coming and going and include weather changes. Automatic Surface Observing System, or ASOS, and Automatic Weather Observing Systems, or AWOS, provide automatic, continuous, real-time weather observations. It's important to remember that METARs are based on observations and TAFs are weather forecasts. METARs, as opposed to weather forecasts, are automatically generated reports about the weather that's occurring right now. They're usually good for about 1 hour until a more up-to-date report becomes available. Temperature and dew point are always reported in Celsius in these reports, and altitude will always be reported in mean sea level, or MSL. On special occasions, altitude will also be listed as AGL, or above ground level. While METARs report the weather that is happening right now, TAFs are forecasts of approaching weather. They're usually issued several times a day and cover roughly a 5-mile radius from the center of a given airport. However, because weather can significantly change in a short period of time, more reports may be required at times. This slide and the next will help you learn how to read a METAR report by breaking it apart into its separate components and putting each one in a separate color. In the United States, every airport has an identifier, and these identifiers start with the letter K. The KBOI shown in this METAR refers to the airport in Boise, Idaho. The number 12 that follows refers to the day of the month. The month itself is not listed in the METAR because it's assumed that pilots will already know this. 1854Z means 1854 Zulu time. This is -7 hours for Boise. 130 refers to wind approaching from 130 degrees. And the 04KT stands for 4 knots, the speed of the wind. To convert knots into miles per hour, multiply by 1.15. So in this case, the 4 knots shown in the METAR will actually be 4.6 miles per hour. How to read the second half of the METAR is explained on the following slide. In the second half of the METAR shown on this slide, 30 SM refers to a measurement of visibility, in this case 30 statute miles. If you want to convert that to feet, simply multiply by 5,280. In this case, that results in 158,400 feet, or about 48.3 kilometers of visibility. SCT 150 refers to scattered clouds. The 150 needs to have 2 zeros added to it to make sense. So in this case, we have scattered clouds at 15,000 feet. 17 refers to the degrees in Celsius 17 degrees Celsius is roughly 62.6 Fahrenheit. And the 16 refers to the dew point, which in this case is 16 degrees Celsius, or about 60.8 degrees Fahrenheit. Remember, measurements in METARs are always shown in Celsius. A3015 is the set altimeter to establish your airport altitude. The altimeter is set in inches of mercury, so in this METAR, 30.15 inches is the setting. Sometimes the numbers in a METAR are squeezed together. Color coding them this way makes it easier to visualize what each part refers to. It's rare, but sometimes a METAR can have another 20 or 30 digits to explain special rain, snow, frost, weather fronts, wind, and so forth. As mentioned previously, METARs always report temperature information in Celsius. To get to a Celsius reading from a Fahrenheit temperature, simply subtract 32, multiply by 5, and divide by 9 to get Celsius. To go from a Celsius reading to Fahrenheit, just reverse the process. Multiply your Celsius reading by 9, divide by 5, and then add 32. Or you could just let Google do the math for you. Humidity refers to the amount of moisture in the atmosphere. The more water vapor, the higher the humidity. And when the humidity is very high and the air is very dense, drone and aircraft performance will go down. A statute mile, the measurement used in the METAR that we looked at earlier, is equal to 5,280 feet. A kilometer, on the other hand, is only equal to 3,280 feet and 10 inches. A knot is equal to about 1.15 statute miles. A nautical mile is equal to about 6,076 feet. If you're going 60 miles per hour, you're going 1 mile per minute or 88 feet per second. Per FAA 107, drones should have a maximum speed of 100 miles per hour, which comes out to about 146.66 feet per second. The METAR we discussed on the previous two slides had a wind direction reading of 130 degrees. This can be easier to understand if you picture yourself standing in the middle of a standard clock face where 12 o'clock is true north and each hour is equal to 30 degrees. So a 90-degree reading would be 3 o'clock, 180 degrees would be 6 o'clock, 270 degrees would be 9 o'clock, and so on. The 130-degree reading from our METAR is equal to about 4:24 on the clock, as shown by the red arrow. So, to review, straight east is 90 degrees or 3 o'clock on the clock face. Straight south is 180 degrees or 6 o'clock. Directly west is 270 degrees or 9 o'clock. And true north is 0 degrees or 360 degrees, same thing, or 12 o'clock. If you need to find north at night and don't have access to a compass, try to find two sticks, one about 3 feet long and the other about 4 feet long. Align the sticks with a bright star and then drive them into the ground 3 feet apart, which is the same as about one large stride. Try to have about 24 inches of the short stick and 36 inches of the long stick sticking up from the ground. Now lie down and align your vision across the top of the two sticks and to the star. Hold this position until you see star movement. This could take about 10 minutes. If the star moves up, it means you're facing east. If it moves down, west. If it moves right, you're facing south. And if it moves left, you're facing north. Finding north in the daytime without a compass is somewhat simpler. Poke a stick into the ground straight up and place a rock at the end of the shadow cast by the stick. Wait about 15 minutes. If the shadow moves up, you're facing east. If it moves down, you're facing west. If it moves right, you're facing south. And if it moves left, you are facing north. Drones are rated into 4 different classes as determined by the industry, manufacturers, and FAA crash and impact testing that determines what amount of damage each could inflict based on its top speed and weight. The first three classes are fairly harmless, primarily due to their light weights. But Class 4 drones, due to their huge maximum weight, require additional approvals and licensing, including an airworthiness certificate. A Class 4 drone can weigh up to 55 pounds and travel up to 100 miles per hour, about a football field in 2 seconds. It's almost like a small missile. Using GPS latitude and longitude measurements, you can pinpoint any location on Earth down to within an accuracy of 1 inch. This is possible through satellite triangulation. GPS will triangulate the coordinates from 7 satellites to provide a precise location. Maps combined with METARs and GPS will allow you to find a safe landing location almost anywhere in the world. The greatest decision makers in history have done things others thought were wrong. In nearly every case, the ones going against the grain proved to be the innovators. Like the sunflowers shown in this clip, they're all facing away from the sun. Why? Maybe they're all looking at a drone? Give it some thought, because when you're thinking, you're growing and advancing. You're retentive. This shows the advantage of a retention learning program like this one. Here's a hint. What time of day is it? If you still haven't figured it out, the sunflowers are facing away from the sun because it's morning. They just haven't turned around yet. We talked to people who took the FAA 107 commercial drone test about the questions they missed and doubts they had from other online training that left them without the answers they needed. We did all this to ensure that our programs would be superior. Idaho Drone Academy uses retention learning programs in which students take possession of all of the training materials forever. This means you don't have to have subscription or even an internet connection to access the learning material anytime you want. The lifetime warranty of our program is that you get to hold all the materials in your hands, and that will never ever retire or go out of business. This video on METARs is offered as an aid to understanding typical test questions on the FAA 107 Commercial Drone Pilot's Licensing Exam. This video is one of a series of videos from our retention learning program. You can check it out and more on our website, idahodroneacademy.com. Thank you for listening.